This talk is about discipline, applying discipline to capturing and coding or capturing and encoding business rules. And we're just going to talk about, look, when you implement a business process, and I'm going to use checking accounts or banking accounts as an example for a lot of this, you end up with a bunch of rules about how you're supposed to process things, or if you're doing a loan or insurance, or I did one where we were doing reviews of business practices, right? We had a bunch of rules that would go and look for fraud and other kinds of things. When we do that, in the beginning, it's super easy. And then you realize a lot of times you end up with a whole bunch of anonymous business rules that are buried in strange places. They're formatted differently. And when you're trying to figure out what the behavior is or what it should be, it can be really difficult. And if you're not going to table drive or business rule engine something, let's talk about a way we can organize these rules, right? So we're going to think about how rules are built, organized, and used. And this is a decision aid, like a concept guide. It is not code. There's not going to be any code in here. Because I probably would write it in a language you're not going to want anyway. But maybe I'll do one in this language just to make it easier. So the scope of this is the justification for organizing business rules or creating a business rule engine. In a lot of cases, we're really just creating a business rule executor, not an engine, because that implies a whole bunch of other stuff. And I've worked with real business rule engines before. A true engine kind of has its own DSL, its own syntax, those kinds of things. And maybe we'll get into that, but I'm just trying to take this from the beginning. Like, what, if you're going to organize your business rules, kind of what are all the things you're eventually going to have to deal with, even though you're going to declare victory on the first day having written something simple. So what is the rule specification? What are the capabilities of that specification? We'll talk a little bit about that. We'll talk about rule sets. That's a grouping of rules into reusable sections or segments or groups. And those rules could be combined in different ways in different rule sets and applied in different places. Rule outcomes, what happens from a rule? What does a rule kick out? We'll talk a little bit about the syntax of an if-then. I'm not really going to talk about DSL. I had another talk where we talked about if-then versus when-then. But you could do DSL. That would be something like a JSON or an XML schema. There are plenty of those floating around where people create a grammar for writing rules in some other language, in a specific language. We're going to talk about how operands are made and really parameters are made visible into the rule engine, and order sensitivity versus order insensitivity. I talked about some of this when I talked about the reading network in another talk. Idempotency and rule writing, that's the ability to rerun a rule and get the same output. And you could run the rule several times sequentially and end up with the same final output. And we'll talk a little bit about functional programming versus imperative models for rule engines, the context, which is actually the thing we pass into the rule to get it to operate against. And you could have it be outbound, but we probably really want to make it something that's passed into the rule execution. And then we're going to talk about side channels of capturing results or errors, because in a lot of cases, the rules really take action. They don't generate results per se. I guess they're results, but it's not like they're post-processed a lot of times, or they could be. There's a lot of different architectures for this. So why are we doing this? And I stated this before. It's because scattered rules are hard to manage. Rules with different grammars are hard to manage. It's hard to figure out how to validate them when they all have different signatures and they smell different, right? And the fact that you have different styles of putting business rules. Some of them are anonymous functions. Some of them are this. They have different, they just have different inputs, whatever. They're testable. These are testable and those aren't, right? So that's all bad. Or it works, but, over time you'd like to get aligned all the wood behind one arrow, as we used to say. And then limit the side effects, surprises. A lot of times when you run business rules, it's like, did it modify the context? There's no contract. I don't know what it's expecting to do. Should the outputs all be outbound calls, right? So are we going to limit we're going to limit the surprises, but we're okay with side effects if that's what we built for. So I'm going to say here, when we build rules, they can either be standalone or they can be embedded. So if I said, if you're overdrawn on a bank account and if you're overdrawn, and then inside that rule I had another if you have overdraft, else if you don't have overdraft. That would be one nested if statement. But a lot of times in business rules, those become two separate rules, and that's so that they can be tested. It reduces the number of paths. But we may end up with something that's moderately complicated on the if side. So we're going to talk about predicate and action. I don't know why those two got reversed, but it's basically the clause that calculates applicability, and then we have a then part, which is the action that we're going to take if the rule is applicable. So when I talked about before about nested rule versus standalone, in this case, what I did is sometimes we will add extra clauses to the if to make it more elaborate. This is especially true in reading networks, but it makes it more elaborate, and that makes the rule more standalone, less dependent on another rule running before it or running inside of another rule. So in this case here, I did if overdrawn and has overdraft. That's a standalone predicate with two clauses in it, and we're good with that. And the other rule, rather than making a rule do two sides of the behavior, we want the rules to take a single action wherever possible. It would be if overdrawn and has no overdraft, then do something, right? So on the then side of this, there's a couple things we can do. We can modify or mutate the context that was passed in. We could modify or mutate data that's external through a singleton. We could generate new data. Hey, when you're overdrawn and you have overdraft, I'm actually going to create a new, what do you call it? A new event, right? In the bank account, and that event is going to be borrow $100 or get $100 of overdraft protection and add that to the balance, right? So I generated a new transaction in the checking account, which was a deposit of $100 from the overdraft account. So another one could be remote action. You see this a lot. Hey, if I'm overdrawn and have overdraft, then send a notice, right? That could be a remote action or it could be a notify. It depends on how it was built. Remote action, in my case, I think of that as synchronous. On the other hand, if I'm going to send an email, that's probably an async, so that would be a tell or notify. We might throw, hey, if this condition exists, we actually communicate with the external system by throwing exceptions, not by mutating the context and not by telling somebody something. Another thing we could do is aggregate. So we could take a bunch of actions, run a bunch of rules, and if the right-hand side, so the predicate is called the left-hand side, the action is the right-hand side. If it turned out I needed to aggregate results, or if I was going to generate a whole bunch of transactions around this overdraft, rather than posting them directly, I might actually return some kind of result and aggregate those, and those would all be events. We might decide, hey, this rule engine always captures events that get, maybe they're observability events or something else, right? So predicate, the if clause, the action side, and that's the then clause. And this one, you could also do it with a when then. So if we look at a rule set is a collection of rules that are run as a unit. This is actually a good way to do bundling. It lets you not write a bunch of long, I was going to use an obscene thing there, a really long method with a whole bunch of stuff in it. Instead, we write a bunch of fairly concise rules, and we run those rules as a rule set. The same rule could run in multiple sets. So you'll see this. I log into my bank account, and it runs a balance check immediately, or a home loan. I'm going to do a home loan, and it runs a business rule around my demographics. And then I did this full model validation, right? Talk a while ago. We may run some rules early in the process, and then at the end, when we hit the last button to submit the loan, we run all the rules that were in all the rule sets to make sure that document actually got validated correctly. So in this case here, with the image I've got, rule tool got included in 2 rule sets. So another thing we want to think about is the rule outcome. Typically, when you first do this, you end up writing, if you're not a functional programmer, you end up writing mutable context, right? So I end up with a bag, some kind of global, some macro size object. In a home loan, it might be the person's credit report and the home loan document that's being filled out. I also saw this in the past on, we regulated brokers. And so when we ran a broker thing, we actually built a giant audit, a giant form. That's what it was. We were signing people up to be brokers, and so they had a multi-page form to do, and we would actually modify the context as we move through it, right? And so that might be really large. The other one might be immutable. You might have a functional programming, and so we might not modify the context. We might generate a new context on each role, and then kind of a shallow copy, send that into the next rule, and at the outside, we would end up with a copy of what the new context would be, and the difference between the new context and the old one and the original one would be what ran. Other kinds of outcomes we can have, a lot of times if you're in a rule engine, the rule engine doesn't just validate something, it actually might make remote calls. So in the case of the bank example I use, when we are overdrawn and we have overdraw protection, we might write a transaction directly to the database to add the $100 to the account so that I'm no longer overdrawn. We might call remote APIs for notification. We might call messaging APIs. So these would be external outcomes where the rule could reach out to some behavior data sync or our partner system. We can get data back from the rule run. I'll talk a little bit about that later. Or we could throw exceptions, and we might decide how that would operate. So if we look at what I talked about before, which is kind of the classic imperative model of mutable context. So I create a bag. It could be a home loan. It could be an insurance policy. Like I said, I also did one where people signed up to be a broker. And basically what would happen is we would run a set of validation rules, and the context would be passed into the rule engine, and the application to be a broker basically was passed in as the parameters for each rule, and some of the rules might have actually mutated that. So address validation would be a good one, right? Hey, you gave me your home address, and we need the postal service, assuming there's still a postal service at the end of this year. We would do a postal service validation on the address and change it to the postal service version, right? And so in that case, we mutated the data that they sent us, and we modified it based on the postal service. But it would be the same object. So the original caller would have this same object, and it would get back. Now, if we'd done that over an API call, that essentially would be an immutable object, right? We would pass the context to a remote service. We get back a modified context. The original is it wasn't mutated, right? And that's because we go across an API boundary. So in a lot of ways, if you do things with microservices, essentially you're looking at an immutable context for your rule engine, like if you put the rules remote. So then we have a mutable chain. This is actually the immutable one. I pass a context in, which is the loan application. Every rule modifies it. And basically I end up with a bunch of shallow copies of this thing, the last one being the one with all the mutations on it. And we did a copy of. All right, so another one would be rule item potency. This is actually pretty complicated. If you're doing remote API calls as part of a rule execution and you're not doing, so some people will gather all the output of a rule and then they'll do the remote API calls. They'll just run a local validation. If you do that, you're good. But if you make, and what that means is those could be idempotent, right? You run rules that don't have external artifacts and generate functional output, and a lot of times can be idempotent. You can run that rule more than one time. But not idempotent means that the data actually got changed. So anytime you have an API call that would then add the $100 overdraft protection, or you did the API call that would send the email out, well, if you run that thing over and over, that one's, every time you ran that rule, you sent that email, that would not be idempotent, right? Because you'd send multiple emails. And the rule itself isn't idempotent, but maybe you could make the API call on the other side do that. So it would go, hey, if you ask for an email on this transaction within the last 20 minutes or last amount of time or tied to this transaction ID, I'm not going to send an email to the person telling them about the overdraft. So you just got to think about whether the rules are idempotent or not. If you built a calculator and you had a business rule that added 1 to it every time, well, if you ran that rule 42 times, you'd be at plus 42, not at plus 1. If it was idempotent, it would be like, oh, we've already run this rule against this data, and we only ended up with plus 1, no matter how many times we ran it. So you kind of have a bunch of strategies around this idempotency. Again, you have an issue if you're calling outbound services or sending messages. And then if you're not doing that, you still have implementation strategies, kind of like the rule that I said before around if you're overdrafting, you have overdraft protection, we're going to give you another $100. That rule might say, hey, you're overdraft and you have overdraft protection, and did we actually create an event that says we're going to add that? Because sometimes those balance changes are actually async, so we would need to know if we wanted to make that idempotent, we would not only need to see if they had an overdraft, we'd need to see if we'd queued up, not just processed, but queued up a request around that. So this one, implementation strategies for doing idempotency, you can do a bunch of guards, right, on the data. The externals might have to handle it themselves. The other thing I've seen is rule generation metadata or tracking information. So every rule that we ran, we ended up capturing a list of all the rules that were run, and if we ran it again, we would keep that pool of rules that had been run, and if that rule had been run. The caching, that becomes a caching clearing problem, which is one of the two hardest problems in computer science. So another thing we talk about is order sensitivity, right? Typically, imperative programmers prioritize rules, and they do that by running them in a certain order. And then they abandon the rules or they do something else if certain conditions are met. And so you can do that, but if you end up using like a ready network or some of these when-then rules, those probably need to be coded to actually be order insensitive. I mean, if you think about it, if a rule is written completely with enough predicate, enough if side, you should be able to run those rules in any order and get the right answer. The place that doesn't work is if the data is mutated and the follow-on rules expect the data to be mutated. But, right? So like you got to figure out where the side effects are required in the rules. Order insensitive, you see that with a when-then, really in some of the like ready networks I've used. They still use if-then syntax, but for all intents and purposes, that's actually a reactive trigger. So when the data changes to a certain format, it runs. And then there's that prioritization thing. So I didn't really talk about prioritization anywhere in the slideshow. But like I said, you can do this order insensitive thing. You make the requirements complete. And actually, I've seen it where the way the ready networks works, you could kind of simulate like that by running rules. And if any of them fire, if they were actually idempotent, you'd be able to keep running that rule set till no more rules ran, right? And that's because the context data might change, and so other rules come into scope, right? So, all right, so, and that was a whole talk in its own, and I'm not going to do it right now. So, context mutation, side effects. External conflicts are commonly modified. Oh, that should have been context. All right, I'll fix that in the docs. So external contexts are commonly modified. You end up with these weird side effects. I've seen this before where you pass a business, like a loan, into a loan processing engine, and we thought that we only made this one change in the interest amount or something, and it turned out one of the business rules actually modified it. So it works best if you can keep the mutable objects, the number down, and then you don't end up with these weird side effects where some rule changed something you didn't expect. You can also do this over an API call because that'll stop anything local from being modified. And the context may be modified. If it's mutable, you end up with these weird things. And those mutations or modifications may actually not be idempotent. The +1 was the example I gave before. Every time you ran a rule that incremented a counter, that modification of the context of the current balance in the calculator, right? That's not idempotent. Another thing, you can have mutation side effects. Now we're looking external. We don't only operate against context that's in memory with the business rules. If we make a bunch of remote API calls, those API calls may have side effects deliberately or accidental. Hey, I'm actually going to run a credit report that would actually might change something on the credit side, for example. So we can end up, the problem when you look at a rule, you could decide the rules aren't going to mutate the local context, but then you make database calls and API calls. So anyway, you just really got to think, do you expect something to be ordered? Do you expect it to be idempotent? And where are you expecting side effects? Another thing we've got is, I'm going to call it a side channel. So the way I've been talking about these rules is they accept a context. They could also look outside for a context. You could make it a locator pattern. But the idea is we pass a context in. So in the case of a home loan, it would be the demographic data, and the loan application would be part of the context passed into a set of validating business rules. The same thing for the broker sign up, right? We would get the broker data and their test scores and all that kind of stuff, and their legal history to see if they were fraudsters and decide whether to give them a license. I don't know if that even matters in the world today, but that's what we used to do. And then you've got kind of these two side channels you can do, right? So a lot of times you can use, if we do the immutable, we actually use the output of the rule as the input context for the next rule. If we do a mutable rule, then we have this result object, or you can actually in the context add a result collection, right? And then you also have this notion of exceptions. Now, one of the things you got to realize when we look at exceptions is you got to decide whether these are interruptible or not. I think I talk about this later, but we may end up with a pile of exceptions and a pile of results. In some cases, we know that when we throw an exception, we want the entire rule set to stop. But in others, that one rule was bad, and we're going to run the rest of them. So I'm going to look, if we talk about the side channels just a little bit here, I did these. The reality is the side channel for both of these could be the same depending on how we do it. But I'm going to really talk about the one at the top because that's the one I just code reviewed recently. So the context gets passed into a rule. The rule modifies the context. That goes to the next rule. Each one of the rules, so if you have a list processor that processes a list of rules, because we're just supposing it's ordered, it could have been a set of rules if they were order independent, but let's say it's a list of rules, then we have two side channels we can do that the rule set process, or the rule engine when it processes the rule set can capture, right? We can run an individual rule, look at its return, especially in the mutable context case, or let's just trying to keep the components isolated. And then we could also have a caught exception, and we could say, hey, a rule set always runs to completion. And maybe the rules themselves check to see if there's any exceptions or whatever, and terminate. So when we start executing the rule, we've got nothing in the return collection, we've got nothing in the caught collection, we've got the context. When the first rule runs, it will return a value. I actually worked a couple of places where we did this just for testing. We only used the return to tell whether the rule successfully completed out, or we did like the equivalent of a HTTP return code, and we had a caught exception collection. So in this example here, we execute 3 rules. The first 2 complete. The third one throws an exception. And then on the side channel here, basically what the rule engine returns is the list of returned objects. Sometimes I've seen it just as voids. Or it could be other things that are more interesting, like a result object. And then we would have one caught, right? The first 2 rules succeeded and they returned a value, so we end up with a 3-element list. The third position is actually empty for returns, and we end up with a 3-element list for caught. I could have done this differently. We could actually not fill the empty spaces, and in that case, we would have to key maybe to a dictionary, and we would say, here's the return for this rule, and plenty of rule engines give each rule a name, and that's kind of cool too. Oh man, I didn't talk about that. And so in the return set, we have a dictionary with the rule by name and what the result was. So talk a little bit about operands. We have design time configuration for a rule, and we have runtime. The design time parameters is basically the configuration of the predicates and the actions, the if side of this and the action, the then part. And so we could just code those, right? I've seen a couple where we end up having a rule with 2 methods in it, 2 constructor parameters, or they're hard-coded. I've seen it where they hard-code the rule, but there are 2 methods in the contract. One is the if side, does apply, and the other is do action, does apply and do action, right? And so we hard-code those. We don't have to hard-code those. We could actually dependency inject those as functions. So you could say new rule, here's my predicate, and here's my action function. So those are at design time. Typically, although I've seen load from a database too, right? So we actually hydrate the rule out of a database. And then you have runtime parameters, which in the case, in all my examples, I'm really just talking about the context. And you can see I have a rule here that takes the predicate and the action function. And it could be a list of actions even. And then we have the rule itself that we run after it's been created, or instantiated. And that just accepts the context, right? And then the rule itself in the actions could either just operate against the context, it could call an API, it could do a database action, or it might invoke some kind of service locator to function to find some other feature inside this code. All right, so your first rule engine that you're probably going to build, to be honest, is just going to be a list processor. If you're not in a functional programming language full time, then it's going to be an imperative, a list of if-thens, and they're going to be ordered. And then it's going to be immutable context, because like very few people have immutable containers. Or it could be a shallow copy for each one, right? And it builds a result, and then it assembles that for the next one. A lot of times you just terminate on the first exception. You're like, man, I kind of coded this like code, and I expect the stop processing on the first exception. I've also worked on these where we never terminate on an exception, and the rules just had to be smart enough to know when there wasn't the right data there, what they were going to do. And then we will end up with some testability. I called it weak here. I don't know why. I think, I don't know why. Actually, if we do this right, weak testability. That's because a lot of times I've seen it where we don't do any return codes, right? We just kind of ran a list of rules, but we didn't put the output anywhere. And then to run a test, you'd have to look at the modified context or something else. I've also seen it where we added return codes and return objects the same way you do would from a web call, and then we could interrogate those to see if they worked or not. So more to consider when you're building a rule engine. Are you going to do ordered or unordered, a list or a set? What is the complexity of the predicate, the if statement you're going to support or require? Are you going to make them really simple, a bunch of very simple if sides, and then those run in order and they end? Or are you going to do fairly complicated so that a rule could be run anytime and it would do the right thing? You also have to decide what the error behavior is going to be. Are you going to terminate on error? Or are you just going to record an error and continue? A lot of times, you know what? Maybe I've worked in a couple on the product rule engine side where we run them all, right? And the rules are coded in a way to protect themselves. If the data is not far enough along, they just don't run, right? The predicate will filter them out. And then you want to capture the failures in a usable fashion. And so that a lot of times is a custom set of exceptions that describe the rule behavior. And then you just got to do the modeling. You got to figure out whether you're going to try and do branched rules, rules containing other rules. I've seen that before. Or whether or rule sets containing rule sets, and the rule sets are predicates. Or whether you're going to do complex predicates. So standardized fine-grained APIs as rule engines. So this is actually like a total sidebar. I've worked a couple places where we didn't put the rule engines in a service. We actually put all the rule engines across a service boundary, whether that was a real service boundary or just a serialization boundary. That meant that the source data being passed to the rule set was immutable. And the API was well-defined because by definition, the API had to be well-defined. And then that would actually capture all of the remote side would capture all of the changes, the results, and the errors, and it would return it in the API call. And it forced us into a certain mode when we used an API rather than you doing everything local. So I think the main thing you want to do is create some common understanding of how your rules are going to operate before you start slinging code. People code first, and then, or maybe you code first, declare some mild first day victory, and then you come back and you're like, man, it's going to get complicated if we add the rest of these in once we get out of the MVP. So you think about how your rules are going to be built, used, and organized. Oh, I flipped that one there. And we want to define how we're going to do a rule and a rule set and what the happy path and error path behavior is going to be. And that's all I got. If I do a code one, man, it would have added so much. All right, have a great day.